Hey, brothers and sisters from the Starknet ecosystem. Welcome back to the Stark Cafe. This is Nurstar speaking, your personal Stark barista. And once again, we are ready to delight you with some very special Starknet content. Hello, Starknet fam. Let's start this week at the cafe on the right foot by having a very fascinating episode about AI and the Giza project, a project which is working on disruptive products at the intersection between AI and zkTech, using the power of validity proofs by Starknet to turn machine learning models into smart contracts, making such models become trustless, verifiable, and more transparent. In today's episode, after presenting the two members of the talented Giza team and after hearing from their inspiring background, we'll have a brief history class about AI before diving deep into Giza, its vision, and its first product, Orion. However, enough for the intro. It's now time to give a warm welcome to Fran and Raphael from Giza. Hello, my friends. Welcome to the cafe. How are you?
Hey, Nostar.
Hello, Sir.
Thanks
Thank you for having us.
Thanks for having us.
It's a pleasure, guys, and it's a pleasure to host such talented builders like you, Raphael and Fran. And looking forward to our session today, which I'd like to ice break it by asking you both to give us a small introduction about yourself and your background, please. Who would like to go first?
I can go first, for example.
Yes, please.
I'm Fran. I'm the founder and CEO of Giza. And previous to being co-founder and Giza, my whole background is on AI. I've been doing AI cloud solutions and in the cloud more than 8-9 years, and heavily focused on the providing highly scalable services for mass usage. Previous to being co-founder, I was the head of machine learning at Adidas, providing real-time services for everyone, basically millions of people worldwide. Before to that, I was also the head of ML of a bank in Spain. I'm based in Spain, by the way. And yeah, previous to that, data scientist and engineer. And my beginnings in my work career are more in the robotics. So I started like doing AI for robotics and joined the blockchain space in 2019. Heavily focused on the Ethereum ecosystem, mainly doing open source contributions, hackathons, things like that. And since early 2022, I started exploring like different scalability solutions on top of Ethereum. That's where I started like exploring Starknet, where I discovered Cairo, its possibilities, and where I started exploring this intersection. Raph?
Oh, awesome. Thanks a lot. Raphael, word to you.
Sure. So I'm Raphael. I'm from Paris, but I'm living in Tel Aviv. I started AI at the university. I worked in Reichman University, where I worked on different models for music industry, how we can generate music with some transformers models. Then I worked in the blockchain space, where we built at Revelator, where we built some blockchain protocols for the music industry, and I started to experiment with AI and blockchain at the beginning of this year, where I started to experiment on this Starknet ecosystem, where I started to build. It was like an experimentation open source project called Cairo-powered ML that is now Orion library with Giza. So I'm leading this project at Giza, and I think we will talk about it more later.
Absolutely. Thanks a lot, guys, for sharing your remarkable background with us and with the whole audience. And right now, let's gradually transition to the main topic of today, which is AI and Giza. And as GPT was launched at the end of the past year, interest and awareness around artificial intelligence rose to all-time highs, making it almost look like something that came out of the blue. However, many data scientists, companies, and nation states have been dedicating a lot of efforts to this technological field for the past few decades and for much longer, actually. In fact, I mean, last week when I was preparing this episode, I studied a bit the history of AI, and I found it pretty fascinating, and I also found some similarities with the history of crypto, such as the fact that the field of AI survived two very long AI winters, let's call them like this, and one between 1974 and 1980, and the second one between 1987 and 1993. So could you tell us a bit about the history of AI, about its birth as a concept in the Dartmouth workshop in 1956, about its hypes and busts, while highlighting also its more modern phase from 2011 to the present, where the whole field seemed to have taken a huge acceleration that eventually led to disruptive products such as ChatGPT, Midjourney, and among many others that are popping out almost daily since then. Could you tell me your view on that?
Yeah, sure. So I think the story started like in 1950 when Alan Turing, the father of computer, published a paper called Computing Machinery and Intelligence. And Turing just suggested that, okay, us as human, we are using available information around us in order to solve problems and make decisions. So why a machine can't do that? So he published this paper, and he also discussed about it and discussed how we can test it. This is the Turing test. But the term of AI, artificial intelligence, was called for the first time in a conference. I think it was in 1956, if I'm not wrong, organized by John McCarthy, which was like a computer scientist, and he organized a conference where he invited like the GOAT researchers, in multiple fields, and the purpose of this conference was to elaborate like a standard and objectives for this new field that he called artificial intelligence. It was a good conference, but it was a bit too short, and at the end of this conference, they didn't have the time to elaborate challenges, and they were like just too optimistic. So they thought that they will be able to mimic the human intelligence like in a matter of few decades, but today we are far from that, even today. So in 1976, many investors invested in that field, and only a year later, it was the invention of the perceptron, which is a single layer neural network. But in the 60s, they realized that it will be much more challenging, and the technology was not ready from a software perspective, and also from like a hardware perspective. You see, so they started we started like what we call the first AI winter, where investors invested much less in that field. But in 90s, during the 90s, it was a very new paradigm where researchers shifted from the rule-based approach to a data-driven approach. So a way how you can learn, how a model can learn from data. You see, so and it's at that time that the IBM launched an algorithm called Deep Blue that competed and won with the world chess champion Garry Kasparov. I think it was in 97. something like that. And and also so it was at that time that Yann Lequin launched the MNIST data set, which is an amazing data set that we're still using a lot today. It's like the hello world of the machine learning field. Why? Because it's really easy to have very good results even with very simple architecture. So when we want to make some proof of concept, we're still using this MNIST dataset, which is a dataset with handwriting digits. And in 2010, we had a huge innovation because it was the born of deep learning. Due to an increase of computational power and also the availability of large data, thanks to the big data, thanks to internet. So at that time, it was the beginning of the deep learning. We saw very interesting models in different that can solve many tasks and different kind of task. So yeah, it was the beginning of the modern age of machine learning, I could say. And in 2017, Google published a paper called "The Attention Is All You Need," and they introduced the concept of attention, which is a technique that try to mimic the cognitive attention of our brain. And thanks to that, they introduced also the architecture of a transformer, which is a kind of architecture that we're still using a lot today, and it is the base of GPT models, for example. And at that time, we started to see many models, and yeah, it was like a boom in 2020 when Transformers and GPT was launched. And in 2022, OpenAI released this ChatGPT. I think with ChatGPT, even if AI was around us for a while, with ChatGPT, users discover the power of AI, because when they use like Google Translate, they common people just didn't know that it was AI. And with ChatGPT, it was clear that thanks to some marketing, it was clear that it was AI models. But we still have many challenges when you are using ChatGPT. You have no idea what they are doing with your data. You have no idea if the result that they return was not biased. You have no idea if they used the model that you asked. For example, you asked for GPT-4 and they used GPT-3 or 2, etc. So it's like a black box, and yeah, it's interesting to see how at all innovation, it was due to an innovation in different fields for software and hardware. And what we try to do at Giza is to innovate in that field and to make sure that we create a transparent ecosystem. So OpenAI is not black box anymore.
I see. Thanks a lot, Raphael, for such a brilliant history masterclass about AI. You know, it's curious to know that a field like the AI one, that's the average Joe would look like a very recent field is actually like 60 years old and older. And I think, the game changer in AI is also due to the, as you were saying, to the technological achievements in software and hardware. So I think we are reaching a point where it's like the right time, to develop also concepts that maybe were too early to be transformed into reality 20, 30, 50 years ago. And having said that, however, after this very interesting historical excursus, we'd better get on the right track to find out more about how Giza is working on the intersection between zkTech and AI. And Fran, would you mind explaining to me the vision and the goals driving the Giza project forward? It would also be nice if you could also tell us a general definition of machine learning models for those of us who are still not very familiar with the concept, please.
Yeah, sure. In terms of Giza, we are basically trying to achieve two main things. The first one is like how to use AI capabilities in the blockchain. This is something that until now was not feasible or secure enough to be done. And in the case that right now you want to use AI in Ethereum or whatever ecosystem, you basically need to rely on the usage of oracles. And this is like basically there are like many different points of failure that could happen from the opt-in side where the model is running, from the oracle side, or from the smart contract side. So what we want to do is, okay, let's remove all these points of possible failure and enrich the blockchain itself with these capabilities that can be completely on-chain without depending on any third parties to be executed off-chain or even in oracles, for example. And the other one is how do we actually empower the open source community to build in the open with the right incentives and with the right guardrails in order to have, for example, alignment, but also an open ecosystem for people to do computation of the inferences. And right now, this is a very opaque environment where everyone relies on the uses of high companies, big tech companies like Google, AWS, or Azure, or even OpenAI, where there is like no clear transparency on what they are doing, how they use your data, and how they execute your models. And basically, they can also, as they have the monopoly of everything, they can put the price they want. Basically, now cloud services have more than 70 or even 80% of gross margin of the computation costs. So it's a lot. And what we want to enable is for all these people to have a fair market where they can use compute resources freely, but also be aligned in terms of incentives while building ML in the open. And in terms of what a machine learning model is, I leave that to Raphael.
All right, thanks a lot.
Okay. So we can see that as an algorithm that can learn that can learn from input and can like we how to say that can just adjust some parameters to be sure that he learned well. And once he found the right parameters, he can this is what we call the training part. And when he knows the right parameters, he can just we can do the inference, which is a way to predict something from the right parameters. So you give the parameter that you learned, and from that parameters you can predict in the future. You see. So you have two phases. You have the training part and you have the inference part.
Awesome.
Yeah.
Cool. Would you like to add something, Fran, or we can go ahead?
Yeah, I was going just to add a little thing. Sorry, Raph, for the unexpected explanation.
Yeah.
For me, like ML model is just you feed a lot of data to an algorithm in order for it to learn how to generalize given a specific set of data. That is like the training part that Raphael said, but also the most interesting one is the inference side. That is, once you feed all this data, how this algorithm can generalize to new data that it haven't seen before. So that's for me the idea.
I see. Thanks a lot, guys, and thanks for this introduction about machine learning models and about Giza as well. And speaking about Giza, you recently launched your first product, Orion, which is a cross-platform machine learning model accelerator. So I would like to know more about it and how it works in practice.
Yeah, sure. So in our, the idea with Giza is to create a transparent AI ecosystem, and we thought that we need an open source project if we want an open source library if we want to build ML models. So Orion library, it's a library where you can make some linear algebra computations, where we also implemented the concept of tensor, which is really important in machine learning, and where we build different functions that are essential to create machine learning models. The idea with this Orion library is to build the same operators that we have in the ONNX framework. ONNX is a very useful framework where for interoperability in deep learning. For example, you can train your model with PyTorch, with TensorFlow, convert it to ONNX, and with ONNX we can convert it easily to Cairo code. So you can make the inference in Cairo. The Orion library is fully open source. You can already use it. We have a very good documentation that we still improve. You have different ways to contribute. You can build operators from the ONNX operator from the operator list. You can also build tutorials. I prepare a tutorial that will be launched like in 1 or 2 days. So it will be clearer for you. Maybe it will be a step-by-step tutorial. You can also build your own models, your own algorithms. Very we have in with Hugging Face, which is a marketplace with different models. In machine learning, where we will list all machine learning models that was built with Orion from the community. You can reuse it. You can publish your own implementation. So yeah, the idea is to make the inference with Cairo. So that's why we created this Orion library. I don't know if you want to add something, Fran, that I missed.
I think it's really well explained. Basically, the main purpose is just to provide the right fundamentals or foundations for people to build on top of Cairo, in this case, verifiable machine learning models. And for that, we need something that is very familiar to what people is used to in terms of working with ML. So that's why we are trying on one side replicate the same interface that in this case PyTorch has, which is like one of the best developer experience for building ML. We are doing the same here in Cairo with Orion. And on the second side is how people can easily extend this framework to support more operations, new functionalities, but also like build on top and plug in different systems, like maybe smart contracts, or maybe just game engines like Dojo, or basically anything?
We have a very good Discord channel where contributors started to implement operators and discuss about future implementations. So yeah, if you are interested to contribute or even just to use the library, I invite you to join the Discord channel.
Thanks a lot, guys, and thanks a lot for this guidance, amazing guidance through the Orion product. And I hope, hopefully, it will be the first of many successful products that will be launched by Giza. And having said that, as we're slowly approaching the end of today's session at the Stark Cafe, it would be very nice to know from you about the Giza future roadmap. And I was also wondering if you're planning to deploy these zk fueled machine learning models on any particular fields, like for example on-chain gaming and on-chain music, for example. So maybe Fran can start with this, and then also Raphael could also go a bit deeper into the music side, as he's very expert about that. And yeah.
Yeah, in terms of the roadmap, we recently launched Orion. We are very focused on improving the library, getting feedback, expanding the contributors that are working on it, but also using it. And what we are now also focused is in building our own platform. Basically, Giza has two sides of things. One is the platform, but the other one is a protocol. So right now we are focused on the platform side, so we can provide a good user experience for people to get onboarded and use what is being used underneath the platform, that is basically Orion. So how people can build their models, upload into the platform, and get transpired into their Orion Cairo representation, and also in how to afterwards doing this transpilation, how to use it basically, right? So from the platform, we are providing what we call validated ML, and this will be open as a service by the end of the year, maybe sooner. And this is where we will provide a high scalable solution for people to run inferences in the cloud that can be verified completely on-chain in Starknet, Ethereum, and basically AVM chains and Starknet.
Awesome. Thanks a lot, Fran. Raphael, would you like to add something? And also maybe going through the on-chain music spin-off, let's say.
Yeah. Okay, I love to experiment with music because music is my passion, and I'm also DJ in my during my spare time. So I love to experiment with music. For sure, I will find a use case how we can use the Orion models to make some stuff with music. What I thought is like maybe we can use a hidden layer Markov chain for on-chain music in on-chain games. That could be very interesting, but this will only be like experimentation. Where I see the huge use cases are for is machine learning, validity machine learning for healthcare, for DeFi, for on-chain games a lot. Yeah, music is fun, and maybe we can find fun use cases, and of course I will experimented with that, but real use cases are for DeFi, healthcare, and other fields, I think. So we in the next few weeks and months we will be focused, yeah, as Fran said, we will be focused on different proof of concepts with different partners.
Awesome. Really looking forward to the next developments around Giza, Orion, and the next products. And, having said that, before coming to the end of this episode and saying goodbye to you guys, I would like to remind all the listeners who would like to know more about Giza and their products to go to their website, gizatech.xyz. And from there, you will also be able to be redirected to their Twitter page and Discord channel, where you will find a lot of info about what they're doing. And also I was giving a look at their careers section, and they're also looking for a Web3 data science lead. So if you interested and you have the capability for that, do not hesitate to get in touch with Fran or Raphael, or I will simply put you through them. And yeah, having said that, it's time to say goodbye to our friends for today. It's been an amazing episode, and I had a great time. And I learned a lot of many things about AI and the Giza project and Orion. And I'm looking forward to having you back at the Stark Cafe in the near future. So thanks a lot, Fran, Raphael.
Thanks a lot,
Thank you,
Nas.
Nasser, for having us.
It was really fun. See
Thanks,
you.
guys. See you guys, and thanks a lot to all the live listeners and to all the listeners in general. Thanks a lot, and it's now time to close. Remember sharing the Starknet vibe, and see you on the next time. Bye. Take care, guys.
Bye.
Bye. Thank you.